So, very good morning, students. So, welcome to IIT NEET Foundation, our Focus C program by Krishnaveni Talent Schools and the Mastermind Schools. So, once again, I welcome all the class 8 students for today's session. As you all can see on the screen, and you are well aware, my subject is physics. We are in class 8th, our ongoing second chapter, motion in straight line. And today we are entering into the session number 4. And of course, is the going to be last session for this chapter. Right? So, motion in straight line, which is the last session today. Today we are going to close the chapter and we are going to start new chapter in the next class. But before going for today's topics, let us recall what we learned earlier in the chapter. Right? So, when you see, as it is a motion in straight line, we learn about what is motion, what is rest, what are the types of various motions, right? Then what are the terminology, terms related to motion, very important. Time related to motion, terms related to motion, like we have distance, displacement, right? Then speed, velocity, right? Then acceleration, retardation, right? Then there is a relation between all these three quantities, which are called as equations of motion, which we discussed in the last class. Equations of motion. When a body is in motion, when a body is changing its position from time to time, it may have distance, may cover distance or displacement or speed, velocity, everything. They are all having relation which is called as equations of motion, where first equation is V is equal to U plus AT. Second one is S is equal to UT plus half AT square. Third one is V square minus U square is equal to 2AS. And of course, fourth one also there Sn, U plus A into N minus 1 by 2. Right. So these are the four equations of motions related to the terms, which are the terms obtained from the motion of a body. So these are the topics we covered in the earlier 3 sessions. And today we are going to conclude the session with some more information that what happens if the body is under the influence of gravity. These all are the motions because they are moving on straight line, right? By application of force. But what happens when the same body is under the influence of gravity? Whether the body is coming towards the earth or whether the body is vertically thrown upwards. In both cases, what happened to these motion, equations of motion? That is the today's conclusion topic, right? That is equations of motion under the influence of gravity. Means how this motion affected by the gravitational force, right? That is a thing we have discussed today before the concluding this chapter. So these are all the topics we covered in the last 3 sessions, no doubt. Okay, starting from motion, rest, various types of motions, terms related to motion. In that again, especially we discussed about distance, displacement, speed, velocity, how many types of speeds are there, what is a uniform speed, non-uniform speed, instantaneous speed, average speed. Similarly for velocity also, acceleration, retardation. Then last class we discussed about all the 4 equations of motion, right? So now we are going to discuss about the Very important topic. That is how these equations of motion changes under the influence of gravity. Right? So motion of the body due to gravity. For example, see, pen is there. I am dropping pen. I am not applying force. The pen is at zero velocity. When I am dropping the pen, it is coming in a straight line towards the earth. So this is called the influence of gravity on pen. Similarly, when you throw pen upwards also, when you throw pen up, it will go up and again come back. That is because of the influence of gravity. So that we have discussed today, right? So there are few terminology changes for the equations of motion. For example, you can remember them. I'll one by one and explain you. No problem, right? So motion under gravity. The force of attraction of Earth on bodies is called force of gravity. So acceleration produced in a body by force of gravity is called acceleration due to gravity, which is termed by small g. Suppose when you are dropping the body, it is zero velocity in my hand. But when you are dropping, it accelerates, it increases the speed and touching the ground with the help of the pull of the earth. And that acceleration produced by pull of the earth is called acceleration due to gravity, which is denoted by g, small g. Okay, small g. The motion of the body under the gravity is important case of one-dimensional motion with constant acceleration, because the g value is same at particular place due to the same gravitational pull of the earth. To discuss about this motion, we shall consider the acceleration due to gravity, that is small g, is constant and directly vertically towards downwards. Then the frictional force due to air is absent, that is motion takes place in a vacuum. We have to imagine, because there is air is there, resistance may be there, with the slightly changes. But imagine that we are in the vacuum, then we have to study about this. Sign conventions, very important. Sign will change. The initial position of the body is taken as origin, that is 0. For freely falling body, means is coming downwards towards the earth. The vertical downward direction is taken as a positive, and g also acts vertically downwards. So a is equal to, right, that we'll see. A is equal to plus g only, because coming towards the gravity. For a body projected vertically upwards, the vertical upward direction is taken as positive. As g acts vertically downwards, a is taken as negative. So out of these four equations, these changes you have to introduce. Changes you have to introduce in that four equations when it is under the influence of gravity. That we'll see. So first case, motion of the body falling freely under gravity. That is, a body is dropped from certain height. And dropped from, so generally, this is an experiment done by Newton. So whenever you are suspending two bodies of different masses, one is cricket ball and one is rubber ball, right? Suppose he took the one feather and stone, right? He dropped both at the same time. Both dropped at the same time. So what generally we'll observe is stone will reach the ground first, then feather will come. Correct? Because gravity is same on both, but due to air resistance, so air acts more on feather when compared to the stone. So because of more resistance for feather will come slowly. But same two objects, when you drop in the vacuum, both will reach the ground same. That experiment is performed from the Leaning Tower of Pisa, Paris. We have the tower. From that tower, they performed, Galileo performed the experiment, and similarly in the vacuum tube also. When he performed vacuum tube, he found that both bodies will reach the ground same, because acceleration due to gravity, gravitational forces same on the body irrespective of the masses. Same thing you can see here in the diagram also. That is motion of a body falling freely under gravity. Falling freely under gravity. Suppose you are thrown. So whenever body is dropped from here, from tower you are dropping. So there is no velocity for the body, right? U is equal to 0. So it is coming downwards towards the gravitational force. So A is equal to plus G. So what is the distance traveled means totally height only. Here there is no distance. We cannot take S. So you can take S is equal to H. Right? So body initial velocity is 0. For every, when body is given as freely falling body, we have to take U is equal to 0, A is equal to plus G, and S is equal to H. These three changes you have to make. V only. Some velocity, whatever that later you can do. So what happened when you substitute these conditions, the equations? First, for example, take V is equal to U plus AT is the first equation. Under the influence of gravity, in case of freely falling body, this equation becomes V is equal to V only. U is 0 and G is here. A is equal to G. So GT. So under the influence of gravity, the first equation motion is given by V is equal to GT. Because U is 0, 0 plus GT. GT only get. Suppose if you got second formula, S is equal to UT plus half AT square. So what is H here? H. H is equal to U is 0. U into A. 0 into anything is 0 only. So it becomes 0. So 1 by 2. In place of here we can get G. GT square. Is the second equation of motion for freely falling body. When a body is freely falling, you have to consider U is equal to 0, A is equal to plus G, S is equal to H, and V is equal to V only. Then the first equation becomes U is equal to U plus AT becomes V is equal to GT. S is equal to UT plus half AT square becomes H is equal to 1 by 2 GT square. Third equation, V square minus U square is equal to 2AS. So V square is V square only minus U square is again 0 is equal to 2. A place is G, S place is H. Or V is equal to under root of 2GH is the equation 3. Clear? Right? It is equation 3. Like this, under the influence of gravity, when the body is freely falling towards the gravitational force, the first equation of motion is V is equal to GT. Direct you can take. Second one is H is equal to half GT square. Third one is V is equal to under root of 2GH. These are the, of course, fourth one also you can write. You can mention the fourth one also. Yes, N is equal to UN plus A into N minus half. Right. So H you can write. H is equal to U is 0, UN is 0 only. A in place of a G into N minus 1 by 2 you can write. The fourth equation of motion. We have to put these conditions. As body is freely falling, you can take initial velocity 0, acceleration is equal to acceleration due to gravity, that is plus because it's coming towards the earth, and distance covered is taken as H because height. Right? So that is the influence of gravity, that whenever body is moving under the gravity, these conditions you have to apply the first case. All four equations they wrote C. Right? Now, the second case, when a body is projected vertically upwards. Suppose you are throwing body upwards. Right? What we are doing? We are throwing the body vertically upwards. So here, this is a ground. Generally, ground represented like this. So a body thrown vertically upwards with some initial velocity. U is equal to some U meter per second. So what happened to acceleration? It becomes minus because a body is going upwards, the G value decreases. And finally, after reaching here, V becomes 0 at highest point. At highest point, you have to consider A is equal to H, and of course, S is equal to H only because H won't be negative. A is equal to minus G, S is equal to H, V is equal to U. Of course, U is equal to U. V value, if it is maximum height, you can take 0. Otherwise, V only. So how this equation changes, you can see. So V is equal to U plus AT, first equation. So V, you can take V only, or you can take 0 also sometimes. So V is equal to, U is nothing but U only. A is nothing but minus G, minus GT. Right? That is equation 1, U minus GT. Second one, S is equal to UT plus 1 by 2 AT square. So what is S? H. U is U only 2 UT plus, because A is minus G, so it becomes minus 1 by 2 AT square. Equation 2. Minus will get here. Similarly, third one, V square minus U square is equal to AS. So V square minus U square is equal to minus 2GH, because A is equal to minus G. This is the equation 3. 4 also you can write same. So whenever there is an influence of gravity, whether the body is freely falling or whether the body is vertically projected, the equations of motions can be changed, where you can use the some conditions. In case of freely falling body, we have to take U is equal to 0, A is equal to plus G, S is equal to H, V is equal to V only. In case of vertically projected body, we have to take A is equal to minus G, U is equal to U, S is equal to H. In case we ask what is the highest, at highest point, at highest point means you can take V is equal to 0. So at highest point, these formulas will change. In general, you are taking V is equal to V low. What is the velocity at highest point means you can take V is equal to 0. 0 minus U minus GT. That is U is equal to GT at highest point, where the body stops and come back to the earth. When you are throwing anything up, what happens? They again come back after reaching the highest point. That means at the highest point, the final velocity becomes 0 and the body comes down. At the highest point, the formulas will change. Similarly, here also, wherever V is there, becomes 0. V becomes 0, here minus minus get cancelled. In case of highest point, the minus minus get cancelled. So U is equal to under root of 2GH will get at highest point. Otherwise, same we can write. We can mention A is equal to minus G and clear. So that is the influence of, under the influence of gravity. Clear, everyone? So that is, so many examples are given further. Note. Okay. The motion under the gravity, so many formulas are given. Total time. Now, after that, there are some more formulas will come. After these 4 equations, we'll get some more formulas like time of flight. So whenever body under the influence of gravity, the special formulas will come. See, in case of motion under the gravity, time taken to go up is equal to time taken to fall down through the same distance. Suppose this is Earth. We are throwing body from here. It will go up and will come down. So this is the maximum highest point, right? Again, it came down like this. So time taken to reach the highest point is called time of ascent. Time of ascent. Time taken by a body to reach the highest point when you throw upwards. Okay. Same time after reaching, what will do? Again came back. It will come back. The time taken to reach the ground is called time of descent. As the value of G is constant, so the time of ascent is always equal to time of descent. Time of descent is equal to time of ascent, which is given by formula U by G. So what is the total? Time of flight. So total time from here to, again, the total time for which body is in air. So when you are throwing the pen, it will come back and to other hand. So the total time it is in air is called time of flight. Time of ascent plus time of descent. U by G plus U by G. That is given by 2U by G. Is a formula for the time of flight. Time for which body remains in air. So time of ascent is equal to U by G. Time of descent is equal to U by G. So time of flight is nothing but time of ascent plus time of descent. That is U by G plus U by G. That is 2U by G. That is your time of flight. time for which body is in air. Total time. Time of ascent, time of descent. When you throw any body upwards, it takes some time to go up, again come down. Whatever the time it takes to go up, same time it will come down also. Both are same. Right? That is called time of flight. One more important point, that is time of flight. Then again comes maximum point also. Maximum distance. So maximum height. Under the influence of gravity, you can find the maximum height. That is, we can call H max. Maximum height. So maximum height, what is the condition for maximum height? When a body is maximum height, condition is V is equal to 0. A is equal to minus G. S is equal to H maximum. At maximum we are calculating, not again any place. So from the formula V square minus U square is equal to 2AS. Right. So V square is 0 at a maximum height. Right. U square you can take it as minus U square only is equal to minus, because G value is minus, 2GH. So minus cancel. So you can write H max. So H max is equal to U square by 2G. The formula for the maximum height reached by a body when it is thrown upwards. H max. So if you ask to find what is, when you are throwing some velocity, 10 meter per second, what is the maximum height reached? So in place of U, I write 10. U square is there, 10 square 100 by 2 into G value is 10 or 9.8. You can take anything. 20. 20 by 100, 5 meters. Means if you are throwing with the velocity of 10 meter per second, body will go to highest point of 5 meters. After that, it will come back again. So these all conditions will come whenever body is under the influence of gravity. Okay. Everything by using this condition, you can find out the velocity, distance, maximum height. Right. Everything you can find out. Even graphically also you can understand the motion of the body. Whether the body is going uniformly, non-uniform, or body is at rest, or body is going negative direction. Everything can be found by the graph of motion. So see, anytime graph, when you are drawing any graph, whether mathematics or physics, what we have to observe is, so in a coordinate system, there are x and y axis are there, right? Horizontal axis is called x, vertical is y. Always x axis is always a fundamental quantities will be. Fundamental quantity always on x axis and derived on y axis. When you're drawing the distance time graph, distance is about position. So time is always on x axis and distance is on y axis. You have to draw like that. So as per drawing, we have so many, suppose. So time is moving here. A body started at one point. If so, the graph like this. What this indicates? Same distance, but time is moving here. That means body is at rest. Body is not changing the position, but time will change anyway. So this graph shows that body is at rest. Okay. Example I am telling. For example, body starts from here. It moves like this. What this graph indicates? Body is moving with the uniform speed. Uniform, it is covering the uniform distance. A straight line passing through the origin. Suppose a body started like this and came down. So here body is moving with some acceleration, again came down with an acceleration. Distance increased and decreased again. So many ways. You can draw so many ways. Suppose like this. Parabolic path. The graph can be represented anyway by using the coordinate system, that is your coordinate geometry in mathematics. So like that, so many graphs you can draw and you can understand. Graphically also you can understand exactly what is the position of the body or what motion body is following. Okay. Similarly, you can draw for velocity and time, acceleration graphs. So many are there. So before discussing about these graphs, which is the last part of the chapter, let me show you one video. Then we'll move to the
heavy green ball with me. If I drop both these balls from the same height, which one do you think is going to hit the ground first? Is it the light orange ball or the heavy green ball? The answer is coming up in this video, because this video is about gravity and free fall. Before we do our experiment, let's first measure the mass of the two balls here. As you can see, the mass of the small orange ball is 10 gram and the mass of the big green ball is 100 gram. As we saw using our measuring instrument, the mass of the green ball is 10 times more than the mass of the orange ball. Now, what do you think about their weights? Remember, the formula for weight is mass into acceleration due to gravity. Now, the value of acceleration due to gravity on the surface of the earth is 9.8 meters per second square. Let's approximate it to 10 meters per second square to make the calculations easy. So let's calculate the weight of the light orange ball first. Its mass is 10 grams. So we need to convert that to SI units. That's 0.01 kg. And if you multiply it by the value of G, we get 0.1 Newton as the weight of this orange ball. Similarly, we can calculate the weight of the green ball. So the mass is 0.1 kg and on multiplying we get the weight as 1 Newton. So again you can see that the weight of this green ball is 10 times the weight of the orange ball. Now when we drop them, which one do you think is going to hit the ground first? Let's try it out. Did you see that both the light orange ball and the heavy green ball hit the ground at the same time? Since it happened really fast, let's take a look at the slow motion replay. As you can see, in the slow motion replay, both the balls hit the ground at exactly the same time. How do we explain that objects having different masses or different weights fall at the same time? You might have been thinking that the green ball should hit the ground first because it's much heavier than the orange ball here. Well, this was Aristotle's theory that heavier objects fall faster than lighter ones. And this theory went unchallenged for almost 2000 years, till a scientist by the name of Galileo disproved it using a simple experiment that we just did. Legend has it that Galileo went up the famous Leaning Tower of Pisa and he dropped two balls, one light and a heavy one. And all the crowd gathered there saw that both the balls hit the ground at the same time. Let's look at the basics. When I drop these two balls, why do they fall down? Due to gravity. Earth pulls all the objects downwards. Now let's talk about free fall. Do you know what does free fall mean? The strict definition says free fall is the motion of a body where gravity is the only force acting on it. So what do you think? Our experiment with the orange and green ball, was it an example of free fall? Let me show you some more examples and you tell me whether they are free fall or not. Remember, free fall is the motion of a body where gravity is the only force acting on it. Is the ball falling down on the earth an example of free fall or not? What do you think? Oops! If you accidentally drop something like this, hopefully not your phone, is this an example of free fall or not? Is the ball falling down on the moon? Is this an example of free fall or not? Landing with a parachute, is this an example of free fall or not? Landing of an aeroplane, is this an example of free fall or not? Well, strictly speaking, it's only the ball falling on the moon. Now, why is that? Because the moon has no atmosphere. There's no air resistance. So the only force pulling the ball down is the moon's gravity. Hence, it's an example of free fall. Now, if you look at the case of the ball falling on the earth, since the air resistance is pretty small, we can neglect it. So then Earth's gravity will be the only force here. So approximately we can say it's under free fall. Similarly, if you accidentally drop something, hopefully it's not your phone and the object is not very light, then we can again ignore the air resistance. So this is also approximately free fall. Now what about the parachute and aeroplane landing? In a parachute, the air resistance is pretty large. That's why the parachute comes slowly down. So it's not an example of free fall. And same in the aeroplane, the wings and engines are controlling the descent of the aeroplane. So there's an upward force. And both in the parachute and the aeroplane, gravity is not the only force. So these two are not examples of free fall. To understand the role of air resistance, I'm going to drop this light orange ball and this sheet of white paper here from the same height. Which one do you think is going to hit the ground first? So let's go ahead and try it out. It's due to air resistance. The paper has a large surface area, so the air resistance is high. The paper is light, its weight is low, so we can't neglect the air resistance compared to the weight. So is the paper in free fall? What do you think? The correct answer is no, because there are two forces acting here, the force of gravity and the air resistance. Now let's look at this small orange ball. The surface area here is small, so the air resistance is low, and we can neglect it compared to the weight of the ball. So the orange ball is approximately under free fall.
चंदू के चाचा की चटनी और बहुत कुछ 10 minutes में और बिग बास्केट.
So that's why this paper takes a longer time to fall, because the air resistance slows it down and the orange ball hits the ground first. But if we did this experiment in a vacuum chamber with no air resistance, then what do you think is going to happen? Both the paper and the orange ball are going to hit the ground at the same time. Let's go back to our light orange ball and heavy green ball experiment. The surface area of the green ball is larger compared to the small orange ball, but the air resistance is pretty low compared to the weight of the green ball.
So anyway, that's you want to explain clearly about the how the freely falling body will act on the lightweight body and heavyweight body, right? So these are the graphs represent the position of the body or motion of a body, whether the body is at rest or whether the body is a uniform motion, whether the body is a accelerated motion, whether the body is a irregular motion. Everything explained through graphs here. So this is about the total chapter. Entire chapter, we have so many levels are there. You have to go through and try for them. If you have any query, you can ask your teacher about the solutions are provided for them. So after completing that, in the next class, when you meet, we'll discuss about the third chapter, very important chapter, Newton's laws of motion, right? Clear? So far, you have done the two chapters. The first one is units and measurements, and second one is about the motion in straight line, where we discussed about, today we discuss mainly about the how the equations of motions will change under the influence of gravity. All four equations with change of some terminology. Acceleration becomes acceleration due to gravity, distance becomes height, and there is some sign convention where to use plus, where to use minus. After those four equations, you got what is the time of flight and what is the maximum height reached. The formulas also you have seen, right? And then we have seen graph, how to draw the graph for the body at rest, body is in motion, body is in uniform motion, body is in non-uniform motion, everything, which explained through graphs, right? So that's all for today. So we have done with our total chapter, second chapter. Now your term is to practice all the worksheets, all the levels available in the material, and write in notebook. If you have any query, you can ask your teacher. They will help you by seeing the solution. Okay. So that's all for today. Thank you very much, students. Have a wonderful day. Thank you.